Yo, this is Mr. O, and today we're gonna go over the graphs of different kinds of function. We're gonna learn about quadratic, square root, cubic. We can also do the cube root and maybe reciprocal function. Okay, let's go ahead now. So quadratic function is a function in the form of y equals ax squared plus bx plus c. Okay, and we know it is modeled wherein the exponent, the degree of the function or the equation is on the second degree or squared. Okay, things that I assume that you know that the graph of a quadratic is called parabola. The parent function, PF, parent function is f of x, let's say, is x squared. Okay. Wherein the best way to graph it, I call it the 135 pattern. So you start at the origin, go up one over, go up three, one, two, three over, and go up five over. One, two, three, four, five. And you don't have a space there. And do the reflection on the other side, and that's how you most likely gonna graph your parabola, your U shape here, and arrowheads. For this graph here, the domain is all real numbers. It goes from left to right, parenthesis, and the range here is the lowest portion of the graph is 0 to infinity. Okay, I like my kids to draw the bullet points, to see it for them to see it. And if you have a function, let's say g of x, let's say it becomes x squared minus 4, that means there's a transformation there that the graph will go down by 4. Okay. So it's going to start at negative 4, 1, 2, 3, 4, and do the 135 pattern again. So up 1 over, 1, 2, 3 over, and then you can do the 5 or you can do the 1 3 only. 1 2 3 over. So the graph of g of x is like a perfect U shape of this. This is the g of x, and this is my f of x. Okay, so you can see that the pattern is that the h of x, let's say this is going to be, let's say, x plus 2 squared minus 3. That means the graph, take note, sorry, the formula here should have been minus here. Minus, my mistake. That should be minus. So this should be, since that's minus, the value of h here is 2. X plus 2 is x minus negative 2, right? So the h here is really negative 2. So that means the graph is going to the left 2. Gonna go left 2 and down 3. 1, 2, 3, because the k is negative 3. And then you can do the 135 up 1 over, up 3, 1, 2, 3 over, reflection on the other side. Okay. And for the red one here, the domain here is from left to right, so negative infinity to positive infinity. The lowest portion of the graph is negative 3 to infinity. If I have here, let's say, another function here, m of x. If the m of x is negative, let's say here it's going to be negative 2 x plus, let's say, 6 squared, and this one here, let's say, is plus 4. That means plus 6, I'm going to go to the negative 6. 1, 2, 3, 4, 5, negative 6. This negative 6 plus 4. 1, 2, 3, 4. That's my vertex. Although here, there's a 2 here. So the meaning of that one, instead of doing 135, you're going to multiply the 135 by 2 times 2. It becomes 2, 6, 10. So that means we're going to go up or we're going to go down by 2. then over, down 6, over, and 10, so forth. Since this is negative 2, we're going to go down. The parabola is going to go down. So from the vertex, you're going to go down 2, over, down 6. 1, 2, 3, 4, 5, 6 over. And reflection again. And the graph goes something like this. And we can say here that the for the m of x, the domain here is still all real numbers, or from negative infinity to infinity, but the range starts the lowest portion, which is negative infinity, and the highest here is going to be positive 4 bracket. Okay? Let's go here now for the square root. The square root is just like an r. Okay? Square root, the pattern that I use here is also called the 135 sideways. Means you're gonna the parent function here is f of x equal to square root of x. Start at the origin, then 135 up 1 over 3 because it's 3 there, up 1 over 5, 3 5. And the graph, we connect the bullet points, and the graph will be something like that. That's why it looks like a letter R. For this f of x, the domain here is starts from left. The leftmost point is 0 to the infinity to the right. What's next? So what if you have your g of x is square root of x plus 4? It's outside, okay? The plus 4 is outside, so just like the k and the parabola, the number outside tells you that it goes up or down. So that means you're going to go up 4. 1, 2, 3, 4. That's your vertex. You start there. Then you do the 1, 3, 5 again. Up 1 over 3, and up 1 over 5, 3, 5. So your graph goes something like this blue one here. And the domain there is still going to be the same from 0 to infinity because you start at 0. But the range changes. The lowest portion of the graph there now is 4 to the infinity. Okay? Learning? Next is the m of x. Let's say the m of x has negative square root. No, don't do negative yet. Let's just have a square root of x minus 3 minus 2. The mean of minus 3 there, you're going to the side now, horizontally. But I know that's negative 3, but you are really going to the positive 3 there. Okay, go to the 1, 2, 3 going here. But at the same time, you're going to go down to 1, 2. And then you're going to do the 1, 3, 5 from there. 1 up, 1 over, 1 up over 3, 1 up over 5, somewhere here. And then you will just connect them and you make your letter R. So again, the domain here starts now at 3 to the infinity, and the range here is going to be from negative 2 to the infinity. Sometimes the graph become like k of x. K of x is negative square root of x plus 5 plus 2. Wherein the plus 5 means instead of going to the right 5, you're going to go to the left 5. Negative 1, 2, 3, 4, 5. Add 2 up to 1, 2. But since there's a negative here, there's a reflection over the x-axis. So the graph, instead of going this way here, is going to go this way here. You will see I'm going to apply the 1, 3, 5. Down 1 over, down 1 over 3, down 1 over 5. 1, 2, 3, 4, 5. So the k of x will have a graph something like this. In the k of x, the domain here is starts at negative 5 to the infinity, and the range there is from negative infinity up to 2. Okay. Let's go now to cube root. Cube root goes the parent function for cube root is the f of x is a cube root of x. Okay. There's so many way to do this one here. I call it three kings. It starts from the zero because cube root of zero is zero. Cube root of one is one one. Cube root of negative one is negative one one. Okay. You can keep going. You're gonna go 1 7 up 1/7 because cube root of 8 is going to be 2. So at 8, 1, 2, 3, 4, 5, 6, 7, 8 up to 1, 2. And same thing, if you have cube root of negative 8, it becomes negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2. So the graph of a cube root is something like a long stretch letter S. Okay. So here you will see it goes to the left and right. So the domain and range here are both all real numbers. Because this keeps going to the left, this keeps going right, this keeps going down, this keeps going up. Okay. But if we have the g of x, same thing with the transformation. If we have cube root of x minus 4, that means all those points will go down by 4. So this point here will go down 1, 2, 3, 4. I start here, up 1, the 3 kings is right there, and then 1 up over 7. This will go down by 4. Go down by 4 here. 1, 2, 3, 4. So the graph there would be something like that. Okay, and arrows here. Same thing, a domain and range here are both going to be all real numbers. While for the m of x, if we put now here x minus 4 cube plus 2, again, same thing. We're going to go right 4. I know that's negative 4, but you're going to write 4, 1, 2, 3, 4, up to 1, 2. So that's the point. And then do your thing. The 3 kings here and 7 to the left. 1, 2, 3, 4, 5, 6, 7. Then down 1. Since I don't have space there, I'm gonna assume it's going to observe the same gap around the middle, and there you go. If I flip it, if I have the say the n of x negative x plus 3 square cube minus 1, that means you're gonna go left 3, 1, 2, 3, down 1. But since there's a reflection over the x-axis because there's a negative here, it will become, the 3 kings will be formed like this now. And then up 1, 7 to the left, down 1, 7 to the right, 1, 2, 3, 4, 5, 6, 7. So you notice the graph goes reversely now, right? And the same domain and range for us there, okay? Let's do the reciprocal function here. Reciprocal function, the parent function there is f of x equal to 1 over x, wherein you cannot have equal to 0 here. You can have you have an invisible 0 here. So the graph for that one, the graph will cannot have x value, and the x value will be right here. And this will never be equal to 0, so the graph goes this way here. That's your asymptote. We call it asymptote. So the graph for that one, let's use different color. The graph will be something like this. Again, what's mainly need to be done is identify domain range. You will see here the domain here. X cannot be equal to 0. So we can say all real numbers from negative infinity to 0, union from 0 to infinity. Likewise with the range, y cannot be equal to 0, or we can say from negative infinity to 0, union 0 to infinity. Okay? Let's give you an example. G of x, let's say here, 1 over x plus 2 minus 3. What's the meaning of that one? The plus 2 here tells you you're going to go left 2. So left 2, negative 1, negative 2, and minus 3. Negative 1, negative 2, negative 3. So that's basically the main point. Your asymptote there will be crossing that main point horizontally and vertically. And our graph will be the same thing. It's gonna get closer to the asymptote here, and same thing with that one. So for the g of x, the domain there, all real numbers except -2, which you can write from -infinity to -2, parenthesis, union to -2 to infinity, and the range here is from -3, so y cannot be equal to -3, or we can say from -infinity to -3, union from -3 to infinity. And that's the idea of graphing reciprocal function. Okay, we'll stop from here, and if you have questions, feel free to ask me. Bye. Always, kaboom.